Hey, and welcome to another day of math. All right, so what we want to do today is continue our discussion on logarithms. We, in the last lesson, introduced you to logarithms, some of the properties of logarithms, and how they were related to exponential functions. And what we want to do today is take that knowledge that we've built on and learn how to graph our logarithmic functions. All right, and what we're going to do is, once again, use that connection to exponentials, all right, to help us with that process. So what I would like you to do right now is do the opener. You have a graph of an exponential function there, 3 to the power of x plus 2 and then minus 5. So if you wouldn't mind, give that problem a shot, pause the video, and then turn it back on. Let's see how you did. All right, my friends. So I'm going to flip over here, and hopefully when you graph this, we had a horizontal shift to the left 2. So you can see there's my new vertical axis. We had a vertical shift of down 5. So there's my new horizontal axis. All right. And then what we said was that we want to do is really graph 3 key points off our exponential. And I typically use -1, 0, and 1. All right. And so 3 to the -1 power would be 1/3. 3 to the first, or 0 power is 1, and 3 to the first power is 3. And so you can see I went to the left 1 up a third, 0 up 1, and then to the right 1 up 3 from our new origin, which is right here. All right, and then there's the graph of our exponential. And this is really a key idea here, because what we want to do today is use what you already know. I think most of you feel pretty comfortable with creating a table of values with exponential functions. So really that's what we're going to do is create on that table with maybe 3 points, 3 to 5 points from our exponential function, and then we're just going to flip the domain and range because we know a logarithm and an exponential are inverses of each other. And you'll see what that looks like in just a moment. So let's go through. I'm going to go back to our main note sheets here. Let me scroll down here. All right, and so here's really what we want to do. All right, when we graph our logarithm is we've already talked about how the base of the logarithm is the same as the base of our exponential. And we want to create a table from our exponential with 3 to 5 points. All right, and then all we're going to do is once we have those points is we know that the domain and range switch. So we're just going to flip our domain and range from our exponential to create the domain and the range for our logarithm. All right, and then we need to graph those points from our new origin. So once again, we're going to find our new origin by doing our horizontal shift, by doing our vertical shift, all right, and drawing our horizontal line in and our dashed vertical line in to represent that. And then we'll apply that a value, all right, just like what we did when we were graphing our exponentials a couple of lessons ago. All right, so when you look down at number 1 here, all right, we're going to try to go through this process with that. And notice I created a table from -2 to 2. You really can just do this from -1 to 1 if you would like. So I'm going to do everything with all 5 points today just so you can kind of see how it adds a little bit to your graph. But feel free just to use those 3 middle points, -1, 0, 1, or -1, 0, and 1 if you would like. All right, so let's jump in. So when we look at our function here, we have our logarithm. We have log base 2, all right, of x plus 8 plus 4. So now notice we're base 2. So if I think about that, we're really working with 2 to the x, right? And so if we were to generate our table values for 2 to the x, just like you did in the opener, all right, and we know that 2 to the -2 would be 1/4, right? We know 2 to the -1 would be 1/2. We know 2 to the 0 would be 1. 2 to the first power would be 2. And then 2 squared would be 4. Now, if we were graphing an exponential, this would be our domain. This would be our range. But we're not graphing our exponential. We're graphing its inverse, which is log base 2. So here's what we know. All right, so if we think about that logarithm has a domain, and then f of x, all right, which is that log, all right, has a range. So what we know is that the range of our exponential becomes the domain for our logarithm. So that means my domain is now going to be 1/4, 1/2, 1, 2, and 4. And we know the domain of our exponential becomes the range of our logarithm. So then that would be -2, -1, 0, 1, and 2. And so now we have our points that we can graph. Well, to graph these points, what we now need to do is our horizontal shift and our vertical shift, all right, in order to find our new origin in which to graph these points from. So when I look at this, notice I have x plus 8 in my parentheses here, right? So this is like x minus h. And so what I can see is that I'm going to have a shift to the left of 8. I have my plus 4 out here. This is my k value, so I'm going to have a vertical shift of up 4. All right, so let me throw in those. All right. So we said to the left 8. So 1, 2, 3, 4, 5, 6, 7, and 8. And we said we're going to have a vertical shift of up 4. So 1, 2, 3, and see if I can manage this a little bit more. Right there, stop. Oh, good. Oh. All right, a little bit of an adventure with my tablet here as we graph. Okay, so now we have our new origin. So we can see, all right, negative 8, 4 is our new origin. Now, I just have to graph my points. And I'm going to just take these 3 key points in the middle just to save a little bit of time, all right, and graph those. All right, so I would go to the right 1/2, and I would go down 1. So right there would be my first key point. 1, 0. So go to the right 1, but I'm not going to go up or down. So there's my second key point. And then I'm going to go to the right 2 and up 1. And I'm going to go ahead and add this next point here. So I'm going to go to the right 4. So 1, 2, 3, 4, and then up 2. And you can see that this creates our curve. So it's going to come right down. Well, maybe a little bit of, right? Going to go down that vertical asymptote. It's going to curve, hit these points, and then keep going. All right, this direction right there. And there's our graph of our logarithm. Hopefully yours looks a little bit better. Now, once again, we want to state the domain and range of this graph. Now, if you remember back to our conversation before, we can see that we have this vertical asymptote, and that's going to limit our domain. So we can see, based on that, all right, that our domain, all right, is going to start at negative 8. It's going to keep going to the right forever, so it's going to go from negative 8 to infinity. All right, and then our range, all right, would be all real numbers. All right, so it's going to keep going down forever. Mine looks like it's really flat, but it really does keep going up as it goes to the right, and eventually we will get all those y values. And that, my friends, is how we graph a logarithm. Let's do one more together, just so you can kind of see the process again. All right, and what I want to do is do basically the same graph, but then once again, talk about how do we incorporate that a value. All right, so this is going to look a lot like what we just did. All right, so we have, this is 2 to the x, right? And so this would be 1/4, 1/2, 1, 2, and 4. All right, and then once again, to get our domain and our range for our logarithm, all right, I'm going to flip my domain and range here. So now the range becomes my domain. So you can see 1/4, 1/2, 1, 2, and 4. And then we have -2, -1, 0, 1, and 2. And once again, we want to now find our new origin. So we're going to put in, all right, those dashed lines to represent our vertical and horizontal shift. So once again, our horizontal shift is to the left 8. So 1, 2, 3, 4, 5, 6, 7, and 8 right here. All right, and then up 4. So 1, 2, 3, and to the right. Keep going a little bit farther. Stay up, you can do it. Almost. Get there. Stop. No. Oh. Tilty. Let's see if I can straighten this guy up here. Oh, there we go. Whew. All right, so you can see that it's really a lot of the same steps as we did before. Now, the only difference with what we did on the prior problem and this problem is we now have an a value other than 1. All right, so I just wanted to make sure that you saw this before you did a couple on your own. So notice for this particular problem, all right, I'm still going to start with this -1 right here. All right, so I would normally go to the right 1/2, and I would normally go down 1. But now, because that a value is 3, instead of going down 1, I'm going to go down 1, 2, 3 right there. I'm still going to go 1, 0, so that's still going to be here. The a value is not going to affect this point because 3 times 0 is still 0. So notice on this point, I'm going to go to the right 2, and instead of going up 1, now I'm going to go up 3. So 1, 2, 3 right there. And if I were to apply this point, I go to the right 4, so 1, 2, 3, 4. Instead of going up 2, I now have to go up 6. So 3, 4, 5, and 6. And you can see what this A value does is it really stretches, right, our graph vertically here. So still going to come down that asymptote there. Going to come up, hit those points, right, and keep going this way. Now, the other thing I wanted you to see here is notice that the A value is not going to affect our domain or our range, right? One, the A value has no impact on our domain. So the domain is going to stay the same as it was, all right, before. So it's still going to be -8 to infinity. And the range is still going to be all real numbers. We may get those numbers a little faster because notice now it's not quite as flat as it was, right? So it's going to increase a little bit faster, all right, but we'll just get to all those points all the same. All right, so here's what I'd like you to do. I would like you to try problem 3 on your own, all right, and give it a shot. So what I'd like you to do is pause the video, work through problem 3, turn it back on, and we'll see how you did. All right, so back at it. Here, let me take a drink of coffee here. All right, so let's see, problem 3. And I'm going to flip to it. I have my work right here. All right, so let's start with our table. All right, I didn't write it in, but hopefully you saw that. All right, that this is base 4. So we're dealing with, all right, the exponential 4 to the x, right? So -2 would be 1/16, -1 would be 1/4, 0 would be 1, 1 would be 4, 2 would be 16. And then if I flip my domain and range, here is my table of values that I want to graph. So now let's go to our vertical and horizontal shift. So our horizontal shift is to the left 1. Our vertical shift is down 5. So -1, -5 is our new origin. Now, when we graph this, we have to be aware of that A value sitting out front, which this time is -1. So notice I would normally go to the right 1/4 and down 1. So to the right 1/4 and down 1. But because that -1, now instead of going down 1, I have to go up 1. Now once again, that A value is not going to affect 1, 0 because 0 times -1 is still 0. And when I graph this point, notice I would normally go to the right 4. 1, 2, 3, 4. All right, 1, 2, 3, 4. And I normally would go up 1, but instead of going up 1, I multiply by -1, I now go down 1. So in essence, this A value flips our graph, which is a property we've already discussed this year, right? That we know that A value changes it from opening up to opening down or increasing to decreasing in this case. So there was problem 3. So hopefully that was not too much work for you, and you can kind of see how that's related to everything we've talked about. Oh, and then real quick, once again, the domain, all right, it's going to start at this vertical asymptote, so it's going to start at -1 and go to the right forever, so -1 to infinity. And once again, that's an open interval because we never quite touch that vertical asymptote. And then our range is all real numbers. All right, let's do one more together. Let's look at problem 4, and I want to do this with you because it has a base that is not, it's a fractional base. Just want to make sure we feel comfortable with that before I send you off to do, all right, the next 3 problems on your own. But once again, if you feel comfortable and you think you can rock this, you're always welcome, all right, to pause the video and attempt everything on your own and then turn it back on, right, or get out the fully worked notes and check your work, all right? So now let's look at it. Our base is 1/3, all right? So we want to think about the exponential of 1/3 to the x, right? Now, once again, if I kind of work backwards here, 1/3 to the first power is 1/3. 1/3 to the 0 power is 1. -1 is the reciprocal power, so that's going to be 3. And then this would be 3 squared, or excuse me, 1/3 to the -2 is going to make the reciprocal of that 3 squared, right? Which is really just 9, right? Okay, so that's 9. And then this would be 1/9 right here. And then once again, once we have this guy in lock, right, we really have most of the problem beat, right? Because now we know, all right, I can just flip, all right, my domain and my range. So now I'm going to get 9, 3, 1, 1/3, and 1/9. And then my range now becomes -2, -1, 0, 1, and 2. All right, and now we can see once again we have this plus 1 here. All right, so we know that this is going to be, all right, a horizontal shift to the left 1. So just very similar fashion to what we just did in number 3 as far as our horizontal shift is concerned. Oh no, it's disappearing. Well, we know that logarithm keeps going forever, right? So we'll just let the asymptote go forever and ever. Maybe if I can get my cursor back. No, 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 no! What are you doing? Stop. Stop. It's got a mind of its own. It did. Oh my goodness. All right. Whew. All right. So let me see if I can straighten this guy up here. There we go, I think. All right, now let's see if I can manage, all right, to put in a our vertical shift if we're down 5. So 1, 2, 3, 4, and let's see if I can manage this guy. Nope, don't dip. Come back up. You can do it. Oh, almost there. Nope, nope, nope. Stay steady, stay steady, steady, steady. Come down, come down. Okay. Nope, nope, not that. Okay. Who knew this would be so hard? Okay, no, no, no. What are you doing? Believe it or not, it's kind of like a pendulum for some reason. I'm not sure what's going on here. All right, I don't know if I'm going to be able to adjust this because I can't really see where it ends. All right, so let me pause the video. Let me see if I can get that fixed, and we'll jump right back in. And voila! There it is. Not quite as dramatic. All right, so now once again, I'm just going to stick to these middle 3 points here. All right, so I would go to the right 3 and down 1, but notice our A value is 3. So I'm still going to go to the right 1, but instead of going, or excuse me, to the right 3, 1, 2, 3, but instead of going down 1, I now have to go down 3. So 1, 2, 3 creates our point right there. All right, 1, 0, once again, is not going to be affected because 0 times 3 is still 0. And then notice I would normally go to the right 1/3 and up 1. So I would go to the right 1/3, but instead of going up 1, I have to go up 3 now because of that A value. That gives me this guy. And then let's see if I can manage this almost. All right. And there it is. Now, and you can see that the domain for this is going to be just like example 3. All right, so start at that vertical asymptote of -1 and keep going to the right forever. And then our range, all right, is going to be all real numbers. All right, so I think you've seen enough. All right, definitely have seen me kind of scramble through and try to work with my technology. Yeah. So hopefully whatever you have is a little bit better than what I have right now. So what I would like you to do is if you flip, all right, to the next page of notes here, you have 3 graphs left. Do 5 and 6 and 7. Try 7, and it is a natural log problem, so it's going to involve base E. All right, so you may have to estimate some values for E there, so like 1 over E, you know, what E is. All right, so just kind of estimate those values, and then we'll talk about how to go through these 3 problems. So once again, do these 3 problems, and you can either turn the video on and go through it with me, or you can check your work through the Fully Works note sheet on the site. All right, so I'm going to flip through. I've worked all 3 problems here, have them up and ready. And I'm not really going to go through the table of values much. I just want to go right to our graph and check some things. So one, notice we do not have a horizontal shift this time. So the y-axis is going to be our vertical axis. We have a vertical shift of down 7 here. All right, and then we have an A value of -5. All right, so notice I normally would go to the right 1/3 and down 1. So to the right 1/3 and down 1. But because of that -5, I now have to go up 5. So 1, 2, 3, 4, 5. Once again, 1, 0 is not going to be affected. All right, so we still have 1, 0. And normally I go to the right 3 and up 1. All right, so to the right 1, 2, 3, and up 1. But with that A value of -5, I kind of get off my graph when I'm coming down here. And you get this graph that is now going to be a decreasing graph because it's flipped because of that negative A value. And you can see that the domain is 0 to infinity. And once again, the range of every logarithmic function is going to be all real numbers. All right, so scrolling down and looking at number 6 here. Once again, horizontal shift to the left 7, vertical shift of up 2. So you can see that designated here. Now notice this time our A value is 1/2. All right. Now notice this is just log. This is the common log, which means we are in base 10. So notice I normally would go to the right 1/10, right? And down 1, all right? But now I have to go down a half, all right? 1, 0, not affected by that A value. And normally I go to the right 10 and up 1. So I still want to go to the right 10, but instead of going up 1, I'm going to go up 1/2. So you can see that this really flattens out. That 1/2 really flattens this curve out. It doesn't have a lot of increase to it. It's still increasing, but it's very, very slow. And then once again, looking at the domain, that's -7 to infinity. And then the range is all real numbers. All right, so let's take a look at our last graph. Once again, this is the natural log, right? So we're base E. And just remember, right, so when you're working with this, remember that E is approximately 2.7, right? So when you're estimating this, right, so notice when we get to this right here, so e to the negative first power is the reciprocal power, so that's 1 over e, right? And so just estimate that. So if it were 1 over 2, that's 1/2, that's like 0.5, right? 1 over 3 would be 1/3, which is like 0.33. So 1 over e has to be somewhere between those two when you estimate. Not that you can see a big difference in the graph here when you estimate that, but just know that. And same thing here. So when we have e, that's 2.7. All right, so you just have to kind of make sure you're in the ballpark there. So 1 over e, -1, and notice our a value is 1 here. All right, so I'm going to go to the right about 1 over e and down 1. Once again, 1, 0 is not affected by that. And then e1, so to the right 2.7-ish and up 1. And then e squared, I believe, is like 7.4. All right, so you can go 7.4 and then up 2 if you'd like. Now, once again, the domain is going to start with that vertical asymptote, so that's -3 to infinity. And then the range, once again, as with all logarithms, would be all real numbers. All right, my friends, it's time for more coffee for me. It's time for you to go practice. All right, so once again, all right, let us know if you have questions. All right, drop in during our office hours, shoot us an email, take a picture of your work if you're stuck, send that to us so we can see what you're doing. All right, and we can give you feedback, send that back to you. But touch base with us if you need any help. All right, have a good day. Take care of yourself, take care of each other, and we will talk to you soon.